variables on both sides. So today we're going to take don't call me after midnight. And we're going to focus on, we're going to add in the me step. So you remember the me step stands for move variables. And when we're talking about moving variables, that means that they are on opposite sides of the equal sign. In order to move them, since they're on opposite sides, we're going to use opposite signs. So we use the opposite signs to move the variables to the opposite side of the equal sign. And just a good tip for best practice is you want to always move the smaller variable. You won't get the wrong answer if you move the bigger variable. You're just going to end up working with more negative signs. So if you can move the smaller variable, you can move the smaller variable when possible. It'll just help you keep it a little bit more simplified. So if we take our don't call me after midnight and we apply it to an equation, it's going to look something like this. Our first example is 10 minus 4x equals 9x. I right off the bat see there's nothing I have to distribute. There's no like terms for me to combine. So I'm right at the step where I'm going to move my variables. I have a negative 4x on the left side and I have a 9x on the right side. So I want to move the negative 4x because it's smaller and because there's more going on here. So if I can move the x's over to the right side, then the x's are isolated. So in order to move that negative 4x, I'm going to add 4x. I'm going to add 4x over here. Because whatever I do to one side, I have to do to the other. And I end up with 10 equals 13x. Now there's nothing I can add or subtract, so I can skip that step. And the last thing I have to do is divide by 13. Divide by 13 in order to get my x by itself. And I end up getting 10 over 13 equals x. And you can leave it right like a fraction like that. 10 over 13 equals x. So now let's look at a little bit trickier one. 3 times the quantity of 3x minus 4 equals 8x plus 4. So right off the bat, I notice I have to distribute here. So when I distribute, I get 9x minus 12, because I was multiplying those, equals 8x plus 14. And now I'm looking, I don't have any like terms. These are different. I don't have any like terms over here. So there's nothing I can combine. So I'm ready to move my variables. If I'm looking at 9x and 8x, I want to move the 8x because it's smaller. So since it's a positive 8x, in order to get rid of it, I'm going to use its opposite sign. So I'm going to subtract 8x. I have to make sure that when I subtract 8x, I also subtract it from the term that has an x on the left side. When I do that, I end up with x, because 9 minus 8 is just 1, minus 12 equals 14. Now I'm going to add 12 so that the x is all by itself. I add 12 and I end up with x equals 26. So now use that to try these two. You'll notice with the first one, there's nothing you can distribute. There's no like terms. So right off the bat, we're moving our variable. Now, even though the -2 is the smaller one here, I don't want to move the -2 over to this side because then I'm going to have to move everything back over to this side. I want to start getting the x's by themselves. So since there is just an x term over on the left side, it's better practice in this situation for me to move the 3x over. Just makes less steps. You wouldn't be wrong if you ended up moving the 2x over, you're just going to have more steps. So in order to keep it as simplified as possible, I'm going to move the 3x over. 3x. -2x minus 3x gives me -5x equals 10. I'm going to divide by -5. And I'm going to end up with x equals -2. My next one's a little bit trickier because I threw in that fraction. But I'm going to distribute that 1/2. So 1/2 of 6 gives me 3h minus 1/2 of 4 is 2 equals -5h plus 1. I don't have any like terms, but I do have variables that I have to move. I'm going to move the 5h because a -5h is smaller than 3. I'll move it over here, making sure to line it up with my h's. 3h plus 5h gives me 8h minus 2 equals 1. So then I have to add 2 to both sides. Whoops. To add 2 to both sides. When I add 2 to both sides, I get 8h equals 3. And then I divide by 8, divide by 8, and I get h equals 3/8, and you can leave it just like that. Fractions are okay. So now let's look at another situation, a little bit trickier. What if I end up with something like 3 times the quantity of 5x plus 2 equals 15x? So you know right off the bat, I'm going to distribute. I'm going to get 15x plus 6 equals 15x. I don't have any like terms, but I do have variables on both sides, so I need to move them. In order to get rid of this 15, I'm going to subtract it. So I subtract 15x on the right side. When I do that, I end up with just a 6 on the left and nothing on the right. So now I have 6 equals 0, which I know 6 doesn't equal 0. So that tells me that this equation has no solution. And it has no solution because the numbers don't equal each other. So anytime you get an equation that ends up telling you one number equals another number and it's not true, like 5 equals 7, 6 equals 0, 2 equals -1, anytime you end up in a situation where the numbers aren't the same on both sides of the equal sign, then you end up with no solution because they're not the same. If you had a situation like this, where when I distribute, you end up with -8y minus 2 equals -8y minus 2. Right off the bat, I noticed that both sides of my equal sign are the same. If I didn't notice that and I kept going and I added my 8y, my y's end up canceling and I get -2 equals -2. When I get two numbers that are the same, this gives me infinite solutions. Because the numbers are the same. So different numbers is no solution. Same numbers on either side gives you infinite solutions.